All right, so today we're talking about something in AI that isn't just another small step forward. No, this is a huge leap. We're talking about a breakthrough that could totally change the game for what AI can even do, and it's called TurboQuant. But, before we dive into the nitty-gritty of how it works, let's just pause on this idea for a sec. Imagine this. What if AI's single biggest limitation, the one thing holding it back, just vanished? Like, overnight. Well, that's kind of what we're looking at. Researchers over at Google have come up with something that gets pretty darn close. We're talking 6 times smaller memory usage, and not just that, 8 times faster speed. But here's the real kicker, the part that sounds almost impossible: zero. And I mean zero accuracy loss. Not a little bit, none. How is that even possible? Okay, let's get into it. Okay, so to really get why this is such a massive deal, we first need to understand AI's biggest headache right now. It's something called the memory wall. See, as these AI models get smarter and smarter and we want them to read like entire books at once, the thing slowing them down isn't their brain power. Nope, they're literally hitting a physical wall, a memory wall. And the main culprit here is this thing called the KV cache. The easiest way to think about it is like an AI's short-term memory, its scratchpad. Now, here's the problem. For every single new word the AI generates, it has to read that entire scratchpad all over again. So imagine you're feeding it a massive document, right? That scratchpad gets unbelievably huge and the whole process just slows to a crawl. Yeah, and this chart right here, it tells the whole story. It's not about compute power. We've got plenty of that. The real bottleneck, the thing that's jamming everything up, is memory bandwidth. That's just the speed at which you can move data around. The AI is literally just sitting there, twiddling its thumbs, waiting for data to arrive. That's where all the time is going. So you might be thinking, well, why not just compress the scratchpad? And people have tried, for sure. But the old ways of doing it were frankly a mess. They were slow, you had to redo everything for each new AI model. And the worst part, they almost always made the AI dumber by introducing errors. Not a great solution. And this is where TurboQuant walks onto the stage. It's not just another patch or a slightly better compression tool. No, it's a completely different way of thinking. It's like a mathematical masterstroke that just elegantly sidesteps all those old problems. And look, the proof is in the pudding. This right here is the needle in a haystack test. It's basically the gold standard for testing an AI's memory. And the results? Just look at them. The original full-power model gets a score of 0.997. Now look at TurboQuant. It's using way less memory. We're talking less than a quarter, and it gets the exact same score. It's perfect. It finds the needle every single time, just like the original. So the big question is, how does it pull off this magic trick? Well, the secret isn't just throwing more computer power at it. It's way cleverer than that. It's all about looking at the data from a different angle. Literally. It all comes down to geometry. It boils down to this really slick 3-step process. First, they do this rotation trick. Now, stay with me here. Imagine you have a bunch of jagged, random-looking rocks. This trick mathematically spins them around until they all look like smooth, perfect spheres. Much easier to describe, right? Then, step 2, it uses something called polar mapping to describe those new sphere-like shapes really, really efficiently. And the final step, the secret sauce, is this tiny 1-bit fix at the end that mathematically guarantees, that there's no error, no bias. And that's how you get to zero accuracy loss. So you can see how this is just a world apart from the old way. The old methods, slow. Had to be trained. Made things worse. TurboQuant, it's instant. It's literally plug and play. The old methods hurt the quality. TurboQuant is what they call quality neutral. It doesn't hurt it at all. And this part is huge. It's data oblivious. That means it doesn't care what AI model you're using or what data you're feeding it. It just works. Instantly. And get this isn't just some clever hack that happens to work. The math behind it is solid. They've proven that this method gets them incredibly close, like within a factor of 2.7 of the absolute theoretical limit for compression. To put it another way, this is pretty much as good as it can possibly get, according to the laws of information theory. Wow. Okay, so the theory is mind-blowing, right? But what does this actually mean for us in the real world? What's the so what here? Well, the impact is honestly staggering. Just look at this table. Let's take a standard gaming GPU, something a lot of people might have at home. Before, you could maybe feed a model like Llama about 32,000 tokens of text. With TurboQuant, that jumps to almost 200,000. That's a 6x increase. Stuff that used to need a giant power-hungry server in a data center, you can now do that on your own computer. And the ripple effects from that are just huge. I mean, this puts super powerful AI into the hands of way more people. Students, small businesses. For big companies, this could slash their server and energy costs by a ton, maybe up to 85%. It opens the door to all kinds of new science and business ideas that were just too expensive before, and it means way smarter AI on our phones and laptops, not to mention supercharging things like database searches. You know, it's funny. When this news first came out, some memory chip stocks actually went down. The market was thinking, oh, if we need less memory, they'll sell fewer chips. But a lot of experts are saying, nope, think again. They're pointing to something called the Jevons paradox. The idea is, when you make something powerful much cheaper and easier to use, people don't use less of it. They find a million new ways to use it. So this could actually cause a huge explosion in demand for AI, growing the whole market. So when you boil it all down, here's the bottom line. For years, AI has been sprinting towards a brick wall, that physical limit of memory, and with one incredibly clever, elegant piece of math, they didn't just climb over the wall. They pretty much just broke right through it. And that leaves us with a really exciting question to think about, doesn't it? We've just knocked down one of the biggest roadblocks in technology. Now that an AI's memory is, for all practical purposes, almost limitless, what are the really impossible problems we can finally start to tackle?